Welcome to the team. As a junior architect, you're stepping into a world where our choices literally shape how applications perform on a global scale. Seriously, I am so excited to have you here. Today, in this explainer, I'm going to mentor you through the very foundations of IT architecture. We're going to bridge that gap from the raw physical hardware sitting in a dusty rack all the way up to massive, globally distributed cloud networks. By the end of this session, you'll understand exactly how all these pieces fit together. Okay, let's dive into the syllabus. We're going to logically build your knowledge from the ground up, starting with bare metal and booting up, then the virtualization revolution, comparing virtual machines and containers, scaling up to the cloud, real-world cloud architecture, and finally, a quick architect's exam study guide.
Section 1. Bare metal and booting up.
Now, before we can virtualize anything, we absolutely must understand the raw physical hardware. You just can't abstract what you don't understand, right? And this brilliantly illustrates those physical building blocks by mapping a computer system to the human body. It makes perfect sense. The CPU, that's the brain, doing all the critical thinking and processing. Your RAM is your short-term memory, holding exactly what you're thinking about at this exact second. Your hard drive or SSD, that's your long-term memory, storing your experiences for later. And that big power supply unit, the PSU, acts as the heart and lungs, pumping life into the entire system. Meanwhile, the motherboard is the skeleton holding the whole shebang together. So what actually happens when we wake this body up? Let's walk through the startup sequence. Step 1, you hit that power button, sending a signal to the PSU to start pumping electricity. Step 2, the firmware, specifically the UEFI, starts up. Think of this like your brain waking up in the morning before you're fully conscious. Step 3 is the power on self-test, or POST. It's basically checking to make sure all the required limbs and organs are attached and actually working. Step 4, it selects the boot device. And finally, step 5, it initiates the bootloader, which pulls the operating system into RAM. And boom, that is the moment the machine gains full consciousness. Moving on to section 2, the virtualization revolution. Once we have this incredibly powerful physical hardware awake, we run into a massive historical problem. You see, in the early days of IT, the strict rule of thumb was one server equals one application. It sounds simple enough, but man, was it incredibly wasteful. You'd go out and buy a massive expensive server just to run a single internal email app. That app might only use, say, 5 to 20% of the CPU and memory. The rest of your expensive hardware just sat there doing absolutely nothing, wasting electricity and physical space. We desperately needed a way to optimize these physical components when they sat idle. Enter virtualization. This introduced a piece of software called a hypervisor to act as a hardware referee, safely dividing one physical server into multiple virtual ones. So the crucial point is understanding exactly which type of hypervisor to use, because there are two distinct implementations you'll run into. Type 1 hypervisors run directly on the bare metal physical hardware. Because there's no middleman OS in the way, they're lightning fast and highly efficient. That makes them exactly what you'll use in production environments and massive data centers. Type 2 hypervisors, on the other hand, run on top of an existing host operating system, kind of like running VirtualBox on your Windows laptop. These are perfect for your local home lab, for learning the ropes, and for software testing. Now, as your mentor, I've got to give you some strict security advice regarding a critical use case for those Type 2 hypervisors: security testing. If you ever need to analyze malicious files or detonate malware, you never, ever do it on your main machine. Instead, you create a heavily isolated virtual machine. Best practices dictate that you run a completely different operating system for the guest VM than your host machine, and you absolutely must block guest-to-host network communication. Doing this creates a secure, isolated sandbox, keeping your actual computer totally safe from whatever nasty malware you're investigating. All right, section 3, virtual machines versus containers. As an architect, one of the most common decisions you're going to face is choosing between deploying a heavy virtual machine or a lightweight container. Let's break down the difference. Think of a physical server as a massive apartment building. Virtual machines are fully independent apartments. They give you maximum isolation, their own secure doors, their own kitchens, and most importantly, their own full dedicated operating system. But because they're fully featured, they're heavy and take a while to boot up. Containers, however, they're just individual rooms inside one of those apartments. They're incredibly lightweight and start almost instantly because they share the underlying infrastructure, specifically the host's OS kernel. The only catch is that the container must match the host's operating system type. Now, what's really interesting about this slide is how clearly it visualizes that structural relationship. Look at how Docker containers sit efficiently inside the larger virtual machine boundary. At the base, the physical server runs the hypervisor. That hypervisor manages virtual machine A and virtual machine B. And right there, nestled inside virtual machine B, you have container A and container B safely sharing the same kernel environment. It's literally a perfect architectural nesting doll.
Section 4. Scaling up to cloud.
Let's see how this all builds into the ultimate scale. We're taking those virtualized apartments and rooms, and we're moving them to the global internet. This is cloud computing. When you transition to the cloud, you have to choose a service model. And honestly, this rental analogy is the best way to wrap your head around it. Infrastructure as a service, or IaaS, is like renting an empty apartment. You get the floor and the walls, the basic servers and storage, but you have to bring your own furniture and maintain the inside yourself. Platform as a service, PaaS, is like renting a semi-furnished apartment. The cloud provider handles the underlying OS and infrastructure, you just bring your application code and move right in. Finally, software as a service, or SaaS, is like checking into a luxury hotel. Everything is handled for you. The cleaning, the maintenance, the services, you just consume it. Think of Gmail or Zoom. You just use the software over the internet without ever worrying about managing a single server.
Section 5. Real-world cloud architecture.
Let's connect these theoretical models to massive, real-world enterprise deployments. Why do industry giants choose the public cloud? Take Netflix, for example. They run their entire platform on Amazon Web Services. By utilizing the public cloud, they gain on-demand self-service and incredible high availability. When a highly anticipated new show drops and millions of people log in at the exact same second, the cloud automatically scales up to handle that massive peak demand. Netflix doesn't want to be in the business of maintaining giant physical data centers. They want to be in the business of delivering entertainment. The cloud allows them to focus purely on their product instead of worrying about the hardware.
And finally, Section 6. Your architect's exam study guide. We've covered a ton of ground today, so let's zero in on the crucial concepts you absolutely need to retain before you head out into the field. Go ahead and take a screenshot of this cheat sheet. Remember these core definitions. The hypervisor is your virtualization manager, the referee. A virtual machine is a fully isolated virtual computer with its own OS. A container is a lightweight, shared kernel box for a single app. Know your rental models. IaaS is infrastructure, PaaS is platform, and SaaS is complete software. And always remember the core benefits of the cloud: instant scalability, the pay-as-you-go financial model, and global access from anywhere on Earth. As you head out to design your very first global application, I want to leave you with this provocative thought. Based on your team's resources and your application-specific needs, are you going to rent the empty IT apartment and build it all from the ground up, or will you just check into the hotel? Your architectural choices between IaaS, PaaS, and SaaS are going to define the future of the platforms you build. Choose wisely, and I'll see you in our next explainer.